Okay, so we want to look at glacier movement now. Now, there's the glacial processes animation in the weekly module. So watch that, and it'll show you how this works. It'll animate the processes for you and show it how you works how they work over the landscape. So the movement is about 1 kilometer per year on a steep slope. And the greatest movement happens internally, and the base slides will vary. That's what we call basal slip, but the upper portion will move faster than the lower portion. And as it does so, because kind of like waves in the ocean, you're going to get these crevices, these vertical cracks from friction with the valley walls or stretching. Okay, so this is in your book, so read the text that goes with this and pay attention to it. But as you melt and refreeze, the bottom will move along, but the top is going to move a little faster, and it's a little bit more brittle. And as it does, you get these cracks and crevices along the surface of the glacier. And here's your mass balance. So here's your accumulation zone where you're adding snow. The weight will press down and compress the snow. Here's your equilibrium line, where it's the pull of gravity exerts more force than the weight of the glacier, and so the glacier starts to move down slope. So you're adding here, but down here you're in the ablation zone. You're starting to get melting and so forth, and you're exposed to the sun, and you start to lose. And so you get a loss here. And the equilibrium line is where, it's the middle of that, where you get a positive gain matched by the negative balance. So the glacier is in equilibrium right there. Anything down here, you're losing. Anything up here, you're gaining. Just a picture of it, but you can see the crevices on top again, and notice, you can see how it's melted there. And so we're losing down here on this part of the glacier. Now, glaciers, just like the wind, just like rivers, for example, they erode and transport sediments. And we call this glacial abrasion, where it scours the canyon bottom and the sidewalls. It will pluck larger rocks that are pulled from the bedrock or the canyon walls. And they will also further abrade the bottom and the sidewalls as well. And so you end up where the original valley was a V shape, but as the glacier moves down, it forms more of a U shape. Okay, so here it is pre-glacial. So here's the stream goes down here, and it's a V-shaped valley. But then over time, as the glacier moves down and erodes the sides and the bottom, it's plucking the rocks off and abrading the bottom. It will form this U-shaped valley, much like a stream or a river eventually. But here's some terms you need to know. Here's your cirques, where the accumulation starts, flows down here into the main ones. Okay, so you're going to need to know what a horn is, what the narrate is. Those are all terms that are going to show up on your test. And then as the glacier disappears, as ablation exceeds, as the negative exceeds the positive, we get ablation, and the glacier will eventually disappear, and you're left with this landform. So here's your glacier trough, this U-shaped trough. Here's your cirques that remain, a tarn, which is a lake that's glacial lake up in the mountains, the horn, where kind of is the high point where the glaciers start, and the arete, the ridges that differentiate the different valleys, tributary valleys there, and then hanging troughs where the glacier has eroded the sides of the valley, and then the water will flow down, and you get these kind of hanging waterfalls, they're called. So know these terms because they'll all be on your test. So cirques are the circles here. Notice these little valleys there. okay? And as they erode away, you get the sharp ridges that are called arêtes, and they divide to cirque basins. So here's the cirques here, and then here's the arête itself that divides the cirque basins, okay? There's the sawtooth or serrated ridges. Cols are where the arête is reduced to a satellite depression, and horns are very common where the cirque glaciers gouge individual mountain summits from all sides. Let me go back one. So there's your cirques, your horn there, and then there's your arêtes, you know, that separates these sawtooth ridges, okay? So the U-shaped valley is what's left. That used to be, again, a V-shaped valley, but as the glacier erodes down, it forms a U-shape. The talus slopes are along the sides because you get material that's fallen down from, you're going to get talus slopes here. Material will fall down the slopes and will accumulate down there on the bottom of the valley. And then you get these transported rocks, erratics we call them, and then the tarns or glacier lakes. And if you get a bunch of them, this chain of small circular lakes, you have what we call paternoster lakes. Okay. Hanging valleys are the valleys carved by tributary glaciers. The Roche Montagne or the asymmetrical hills of exposed bedrock. And then very common in New Zealand and Norway are the fjords, these U-shaped troughs that are pushed down into the ocean. And the glaciers will erode underneath the seawater, but when the glacier retreats, it leaves behind that carved out space and it fills up with ocean. So here's your landform. So here's your arete. Notice the sawtooth, these very sharp ridges. Here's the cirque up here. Here's the col. And here's the horn over here. And of course the glacier's retreated and is gone now. Here's your hanging waterfalls. And down here you can kind of see the talus slopes. So the glacier tributaries would come down here, and then they erode the smaller valleys. But once the larger glacier is gone, the water from the melting snow will fall down as like a waterfall, take rock with it. So you get this accumulated rocks down here that we call talus. Okay, so we'll stop here and then do erosion and landforms on part 3.